Hello friends, welcome to our YouTube channel, and in this video we're gonna see how we can do the preliminary sizing for our curve. Okay, so in this video I'm just gonna introduce the tool that Autodesk Civil 3D has built in. We are not going to analyze the surface properly. That I will do in one of the video that would require separate tutorial series, maybe one or two videos to cover all those things. But in this video, we'll see just calculating. We have already seen, inserting the culvert and creating cross section. So let's go ahead and see the tool where we have it located. Okay, so in the tab here, in the Analyze tab, over here at the top, in the second page, you have the design option. Okay, as you click over that, you have four options. Today we are going to talk about this Launch Express. Okay, so Express Hydraflow Express is the tool that we're gonna use for this particular video. So let's click on it. So it opens a window where you can see obviously there is a culvert. So you can design culvert, channels, inlets, like a curve inlet and this kind of hydrology. This is for the calculation of quantity Q and weirs also of different shapes. Okay. So for this tutorial, we are limited to culvert. So I'm just demonstrating, what we can do here. Okay. So for that, what you need, the most important thing is you need the cross section. I have already shown how to create a cross section, and the video I will just put the link below in the description. From that, you can have all these elevations that you have. Furthermore, we would require, based on your locality, you would require other datas like Manning coefficient and other things, depending upon the type of terrain you are dealing with. Okay. So first, let's see what is the requirement you have. But let's look at the interface. So at the top, you have these bunch of options: file, edit, and help. And then you have these options. We will discuss them later. The first thing we have to look at is right now it's in the American system. Okay, so let's change it to SI. So here you have option to change. That's the units. So let's click on it, and it's US customary. We can make it to SI. So convert data. We say yes. Okay. Okay, so it's successfully converted. Now we have, for the calculation, we have the data here. And the data is pretty much explanatory as we have a diagram also over here. Okay, so we can see. And below that, we have a table. So it's Q, velocity, and depth, and HGL, everything is here. So after calculation, these data will be available, and even this image will be updated. So let's go ahead and see what we have here. So section, it's a pipe divided into three sections: pipe, embankment, and calculations. Okay. So first one item we have here is invert elevation. This is DN for downstream. Whenever you click on particular option, here at the bottom, you will have a short explanation for that. Okay. So when I say click on the length, so what length is about? So it's a enter the culvert length. So length of the culvert. So culvert length will not finish here. Maybe it will go a bit further, so that you can enter. So first, let's enter the downstream elevation. Let me just keep it at maybe, based, it must be, the data must be from your cross section. So let's assume like we have, let me go there. And so I have a reference. Let me go back here, and I have a reference for this reference, the downstream right now. Okay, later I think I forgot to save it, so it's right now like that, but no problem. For reference, I will just check this. Okay, and 305. So 300 around meter is our data. So it should be, let's make it 305. Okay, meter. Then length of culvert. So here, what's the length of culvert? It's around 12, 11.75, 14. Okay, so around 25 meter. Okay, let's put it like 25 meters. Okay, 25 meter. Okay, then the slope percentage. Let's assume we can level the slope here as well. If you just click on this particular cross section, you will have option to level and you know add levels. So you can add the grade level. So you can just put like that. Just make it sure. So it's around 2%. Okay, so remove it and just put it at 2%. It's asking percentage. Okay, so 2%. And up elevation it will calculate as you enter the, but the downstream invert level. So it will calculate from the slope you get, or you change it and then it will calculate. And now there is a rise. What is the rise? Rise is the height. Okay, height, and this is a pipe flow right now. Okay, so the rise, let's say we have 1.5 meters of culvert. Okay, rise in mm. Okay, it's in mm. Okay, so make sure you enter in mm. So we say 1500. Okay, enter. Okay, so 1.5, and let it be circular for right now. We can choose, actually we have a drop down here. We can choose circular, arch, elliptical, like that. Okay, so let it be circular for right now. And then span from rise, it is saying, because it's circular. Okay, so it should be equal. Okay, if it were, box, so span is width actually. Okay, rise is height and span is width. So now you can enter different value. Okay, maybe I can enter like this. Okay, but for circle it should be same. Okay, so you see it changes quickly back to the circle. Now number of barrels. So we let's assume one only right now. N value I will keep it default. You can just choose it from these. You have a drop down for N values. This one is fine. Culvert type is right now circular, as we saw, or you have even this one is circular concrete. So depending upon the materials, the values, and the sea, everything will be changed. So I just keep it concrete for now. And then entrance. How is the entrance? So there are losses, certain losses because of the entrance. So that you have to take into accounting. I will just say square is, as this is the common. Okay. And the top elevation. Now this is about embankment here. At the top, you can again go back to cross section and find the top elevations. Okay. For here, I will just enter. We put it like 3.5. This one, so 1.5. Let's put it like 308, something like that. Okay, top elevation. Then this value will be, why we are entering, it will be displayed later. So for top width, let's say if your culvert is 24, and the top maybe we just say 15. Okay, and then crest length, till here is it's a enter the length of the embankment crest, use as a weir crest for our topic of flow. Okay, so till that flow, what is the length? Okay, so maybe we say, maybe it is maybe 22, something like that. Okay, more than 22, maybe we say 24. Okay, these all data should be entered from your cross sections. Actually, I'm just putting in here, and this q has to be calculated from CIA, from hydrology here. Okay, so for this I will just assume something, and I will just input it. Let me assume for CIA it's for SI. Yeah, you should be very careful with this value. This is 0.278 CIA. Okay, and I will assume C as 0.365. Okay, and area as maybe half kilometer, square kilometer. Okay, half a square kilometer. And then intensity of rain, average intensity, like return period is 100 years, or whatever, 50 years, whatever is your local practice, take accordingly. I say it's 60 mm per hour. Okay, and based on that I can calculate my q. Okay, and then we can also calculate q max, okay, based on the maximum of the return period, for the given return period. So 0.365 into zero point 0.5 into 60. Okay, so it comes out to be 10.95. Okay, so maybe it's in cms, means cubic meter per second. Okay, and let's say its maximum is 11. I just round it off. And for minimum, all the time you will not have maximum, so minimum, let's say maybe always we have 3. Okay, that's all. And there is incremental. Okay, so how much increment you want? Like if you say 1, then it will calculate for 3, then 4, then similarly it will go to the 11, like in stages. Okay, so based on your local practice, so that the flow, and how it is monitored. Okay, And depending upon that, the type of the flow also will vary. It will not always be the full flow. Okay, so now this one is tailwater. Here, tailwater level. So you can set the tailwater level for this critical plus diameter by half. Okay, at critical flow plus diameter by half, or you can choose from the drop down. You can even set yourself what's the level. Okay, or you can choose crown, normal, this level, or normal, or critical. So for this case, let's keep it normal. Okay, and just run it. So once it's running right now, once run is complete, you will have this kind of data. Okay, so you see the this particular uh, this earlier diagram is here, but the plot is here with all your data. And you see the elevations what we provided, it will draw a profile based on that. And even this horizontal is meters in the length, and this one particular is in the elevation. So this is how it draws. First one, first step used is this one. Then second one, as you click over it, the results changes. You see now it's going over the top, like so. And then continue. You see now we know this particular size of the culvert is not sufficient, because it's already, now it's the embankment, it's even going over the road. Okay, so if we go to the end, till the end, you see it's already going over the road. So now, for the sizing, we can change the size now. So let's say now maybe we say two barrels. Okay, we increase it. Okay, and let's say run again. So it runs quickly. And now you see this one, and let's go to the last one. Okay, so now you see it's better. Okay, and it accommodates if we just put it two. It's great. So this is the way you can run the analysis and do the sizing for your culvert. And even just we can, it's dynamically linked, so you can make it box. Okay, and box, and let's say we keep it like that, and this again say run. Okay, so it will run quickly, and it just replaces the value. Okay, so it's better, so it quickly runs. So it's very dynamic, and you can change it and quickly you see results. Even you have option for the plot. Okay, so you see it is plotting the inlet outlet control. You see the top of the culvert is here, and at what value of the inlet flow at the inlet, it goes beyond the top of the culvert. Okay, so it's also showing that. Okay, now you can even what you can do is you can actually print it. Okay, and you can print the results grid, just results grid. Okay, this one we just print it, and let's say it will ask you to save, and you just save it somewhere. And then you have the table. Okay, print it, calculation table. And further you can actually print the whole report. Okay, so you can print report again same way, and you can choose all the customizations that you can do, and then you have the report in one. So the paper size wasn't good, so it is like this. Otherwise it would have been better. We can choose a better paper size. Let's say more settings, the layout, I say okay, at least A4. Okay, and say okay, and let's say print it again. Okay, let's print it again, and save it again, replace. So as we print it, it's there. So right now you see this particular chart is available. But if I want another chart, okay, another chart, because right now this one is plotted. So this, if I want, then I can now print it, and then it will print. I will just put it into landscape so that it fits properly. And let's say the proper size, maybe paper size to A4, and say okay, and print it. So it will ask you for the location to print, and just save your file. Okay, and then you have the report printed. Okay, in a way it's properly printed. So you can check it, and submit it. It's very good for preliminary design. Okay, so make sure when you are printing which result you want to highlight. So there are multiple results. So if you want to highlight the last one, okay, so you just select last one and then click on the print. Okay, then that will be available. So you see, right? Let's print it again. Let's close the report so that it will be replaced easily. No problem with the replacement. So now you see the last one is printed. The image that we had, the plot that we had for the last one is shown here. Okay, so make sure which one you want to choose, so that way you can print it. Furthermore, what you can do is you can just save it and save it as .hxp file. Okay, you can save it as .hxp file and later can open it easily. Okay, so this is all. What more you can do is, so you can, for the name, you must have seen this name particular here. So from here you can name it. Maybe you say box Culvert design. Okay, and then say okay, and this one here, sorry, this one updates as box Culvert design. And even you can see right now it's filled with the colors. So these colors you can toggle between the colors. So you just want a line, that's fine. If you like the display of these colors, then you can put it like that. Okay. So and another thing is you can toggle up the this HGL is higher. You see, over there is a faint line. You can toggle on and off. You can even zoom into certain part. Okay, so click on zoom, and then where you want to zoom in, you just zoom over there. Now you can see this HGL line a little bit more clearly. Okay, and if you want to zoom out, first let's see zoom extends here. You just click on it and it zoom extends. If you want to zoom out, just click on zoom out. Okay, and if it's zoomed, let's zoom in first. Okay, and then say zoom out, then it will zoom out like that. Okay, and here you have grip also to drag it, scroll. Okay, so here in the another plot, for plot here you can have a performance curve with depth to flow rate as well. Okay, so there are a lot of things that you can have. You can just manually also sneak this stuff and then put it in your report. So it's good. So that's all for this video, guys. See you guys in the next video. Have a great time. Like, share, subscribe to our channel.